Our final problem is a problem where we're dropping an object. And when an object is dropped, as long as you ignore air friction, this is always going to be the equation. Its height in feet above the ground after t seconds can be modeled by the function h is equal to negative 16 t squared plus h with a subscript of 0. We would usually call that h naught in your science class, physics probably, where h naught is the initial height in feet of the object. And so as an example, the graph of h equals negative 16t squared plus 200 represents the height of an object dropped from an initial height of 200 feet. So whatever that initial height is, you just plug that in for that initial h value, your initial height. So for a science competition, students have to design a container that prevents an egg from breaking when dropped from a height of 50 feet. We want to first write a function that gives the height, h, in feet of the container after t seconds, and then figure out how long it takes the container to hit the ground. So our equation that we will use is just simply h is equal to negative 16t squared plus 50, because our initial height is 50. So this is the equation we're using. And in order to figure out how long it takes to hit the ground, we need to figure out how many seconds t that it takes for our h, our height, to be 0, because hitting the ground means our height is 0. So let's go ahead and set that up. 0 is equal to negative 16 t squared plus 50. I notice that I don't have a middle term here. I don't have something times just a plain t. So this is going to lead me to using square roots. If I'm using square roots, I need the squared part on one side and the constant on the other. So I want to move the negative 16t squared to the other side by adding to both sides. 16t squared is equal to, the negative 16t squared is gone, and we're left with 50. I want to continue solving by dividing both sides by 16, and that's going to leave me with t squared is equal to 3.125. This is one of those times when using decimals is okay, when we're dealing with real world problems. We are now ready to take the square roots in order to undo squaring. So the square root and the squared cancel here, and we are left with t is equal to 1.77. Don't forget that this should have a plus and a minus on it, at least initially, but we want to think about those answers. Time can't ever be negative unless you have a time machine, and then please share if you do, but unless you do, time can't be negative. So we want the positive only, because time can't be negative. So taking the positive case only, t is equal to 1.77 seconds. Let's go ahead and look at the part B, and it says find and interpret h1 minus h1.5. That simply means that we are going to plug in a 1 where we see t and see what h comes out to be, and then do the same thing with 1.5. So h of 1 is equal to negative 16 times 1 squared plus 50, and that's going to give us a value of 34. H after 1.5 seconds is negative 16 times 1.5 squared plus 50, and that gives me 14. So between the seconds of 1 and 1.5, I have moved 20 feet. 34 minus 14 is 20. So let's go ahead and say that in words. The container dropped 20 feet between 1 and 1.5 seconds.